Let's talk about AI.
Yeah.
In 1977, computers entered the world of mathematics. The four-color theorem was one of the first major theorems that was solved with the assistance of a computer. And since then, computers have just taken over computations, calculations, data analysis. Artificial intelligence is now becoming this giant elephant in the room of many different professions. How do you envision your field, the foundations of mathematics or analytic philosophy, changing or evolving with artificial intelligence? Would that happen? How would AI fit in? Do you think it's possible that AI can derive mathematical proofs and not just derive them, but also rank them, like separate the wheat from the chaff?
Mm-hmm.
And how do you envision the role humans will start playing this dynamic hybrid relationship in the future?
Yeah. I mean, it's a great question, and it's obviously so open-ended as to it's hard to know where to start. Let me say, first of all, what I think is good for philosophy about this AI revolution. So, I've mentioned it a few times, like foundations of physics issues and stuff, and how it's been relegated mostly to philosophy departments. I say relegated because I think many physicists, at least, have a sort of lowly opinion of anything philosophical, and
it's too abstract. It's not practical.
Who knows? I don't. I think that
that's their comments, not mine.
Yeah. Maybe that's right. I don't know. I mean, and I also don't want to. There's plenty of physicists who are very interested in it and stuff. So I don't want to make it sound like 9 out of 10 would say that or something. But maybe a significant minority. But in recent years, technology has brought foundational questions more to the forefront. Namely, quantum computing has made questions about, one thing I'm struck by, I'm no physicist, but, I like reading physics books, and you never used to, in the physics books from the 70s, there never used to be much focus on things like the Bell inequalities or the any of the action at a distance, entanglement stuff. That was kind of a specialized topic. It was solving the Schrodinger equation.
Yep.
And that's always in the books now. And in fact, I mean, in my experience, the new books, and in fact, a lot of books are just on what amounts to really simple quantum mechanics, because it's really quantum computing, but it's all about entanglement, So there was I think a practical pressure to start looking at these theorems, and you can't look at the Bell inequality very long and not think about foundations of quantum mechanics.
Yeah.
So now I think that, foundational issues are ingratiating themselves, forcing themselves, maybe is the more appropriate term, into physics proper in a way that they just didn't have to for the practically minded physicist in the 70s. I think there's something similar going on with the AI stuff and foundations of math. So of course, those who follow this stuff will know that, math and philosophy were deeply engaged at the turn of the 20th century. And as we've been talking about Russell, for example, he was a philosopher by training, and, and of course, Gödel was 1 foot in philosophy, 1 foot in math. And Hilbert, maybe the last great universal mathematician, was, deeply involved with philosophical questions and programs, and something called Hilbert's program was among them. He's the famous guy he's the guy who gave the list of problems for the 20th century, and the first on the list was solve the continuum hypothesis, and then the logicians showed that you can't prove it and you can't refute it, and then the 10th, I think, was come up with an algorithm for solving Diophantine equations, and then the philosopher Putnam, Julia Robinson, and some other people proved that there is no algorithm for that. So anyway, the thing that I think is going to force mathematicians once again, force is too strong. I think the thing that's going to interest mathematicians once again in philosophical questions comes directly from this technology. And here's the issue. The issue is, okay, so one question is immediate, and it comes from reflection on the 4-color case, which is, what is a proof? You didn't have to worry about that for much of the 20th century. There was a view in the background that if you really wanted to get to the bottom of it, you'd go to the philosophy department and ask the logicians, and they'd tell you, well, a proof is something that could in principle be formalized in something called first order ZFC, maybe with identity, blah, 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 with first order logic with identity, blah, 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 blah. And if there's a surrogate proof like that, then in principle, a machine could check that was a valid proof and tell you after a finite number of steps, like a Turing machine could check. And that's what a proof is. But of course, you don't generally need to know that, because, the way proofs are checked in math is you send it to an expert and you send it to another expert. And if there's enough agreement, a thumbs up. It's very rare for there to be a case where it doesn't end there. There is a case like that right now with the ABC conjecture, but it's very rare for that. So, there was an answer that the philosophers came up with at the turn of the 20th century to what is a proof. And, most people didn't need to know it because you don't really need to answer that question almost ever. Okay, but now we're programming computers to check proofs, to generate proofs, to assist in proving. So there's the question how to program it. Well, you can't very well decide that without taking a stand on the question of what axioms are true, what logic is correct, what does that mean?
Yeah.
So, for example, some of these, my understanding is that one of the most popular theorem provers, or at least maybe it's a theorem checker, I can't remember, uses intuitionistic logic, which is a non-classical logic. Where the law of the excluded middle is not valid. So what does that mean? Does that mean like if Google gets a monopoly and they use a proof generator with intuitionistic logic, does that mean intuitionistic logic is the true logic of the world? Of course not. So there's no way of avoiding any longer the questions of, it's kind of like if you were to, with self-driving cars. Mm-hmm. And you program what to do to maximize utility in this circumstance, or what's the right thing to do in this contingency. There's just no avoiding taking a stand on that question. And presumably you want to have some sense of what the hell you're doing when you take a stand on that. You don't want to arbitrarily stipulate an answer. You want to get the right answer, it feels like. Yeah. Okay, what does it mean to get the right answer? We have, we've been talking about what that could mean in the ethical case, but what does it mean in the mathematical case? Is it like physics, where most people think that whether there are gravitons is not the kind of question that is a matter of convention? Or is it, like the, say, case of whether to put your fork on the left side of your plate? Is it, or drive on the right side of the road, where, it's a norm, but there's no deep answer to who's really right. So, So what are the questions that come up now that I think that there's going to be no avoiding among the mathematical community generally? What's a proof? That question has been with us since, as you say, the proof of the four-color theorem, where ineliminable use was made to check zillions of cases and stuff. But I'll give you an example from logic that. Sorry, let me finish that thought. Okay, so what is a proof? What does it mean to say that one system of proof is correct? What axioms are true and or correct, and what does that mean? And who decides? Like, how do we figure this out? Like, what's the methodology? Do we take a poll? Do we leave it to the richest IT company? So this is, I think, going to be unavoidable. But let me give you an example of how I think the terrain is changing. So, right, you got this four-color theorem proof, and there's, the Kepler conjecture was another case. There aren't, though, that many cases where you had something that the mathematical community had to finally say, okay, I mean, it's a proof. I don't like it, but it's a proof, but I can't survey it, but it's very likely, if you're asking about what's more likely to be true, the four-color theorem has probably undergone dramatically more scrutiny than a typical proof in a mathematics journal that's just a few human beings specializing in that area saying, yeah, it looks okay. Yeah. So in terms of if a proof is just making something very likely to be true, or more carefully, making it very likely that it follows from the relevant axioms, the four-color theorem, the Kepler conjecture, these things have certainly been proved, but there haven't been that many cases where you just had to defer to a computer like that. But I think things are changing. So I'll give you an example from as I say, the Baroque area of logic. But speaking of its unusual status, I think that this might actually affect the status of the subject of the proof. So the philosopher W.V. Quine famously came up with an alternative set theory in the 30s. So, we were talking about the status of set theory. Is there a pie in the sky answer to the question, what are the true axioms of math? And I think, to be frank, if you asked 5 different mathematicians, you'd get 5 different answers. But if you were asked instead the question, what are the axioms of math? They would probably say the ZFC axioms, and maybe they'd know what they are, maybe they wouldn't, but whatever. Okay. So I was illustrating how, I think that there's a lot of contingency, that the ZFC axioms were adopted as the axioms, and that there are lots of alternatives that one can entertain. And when you think about them, it's hard to see how there could be like one true fact about what are the axioms of math. Well, a great illustration of this is Quine came up with a system, and it attracted a lot. It's called New Foundations for Mathematical Logic. It attracted a lot of attention in the mid 20th century by some of the best logicians in the world. Rosser, in fact, who is the guy who cleaned up Gödel's proof. Gödel's proof originally was if the Peano arithmetic is consistent, it can't prove the Gödel sentence. And if it's omega consistent, it can't prove the negation. Rosser showed there's actually a way to make this. If it's consistent, can't prove the Gödel sentence, or Rosser sentence. And if it's consistent, merely consistent, it can't prove the negation either. Mathematical Logic book was written based on Quine's theory. Jensen did a really interesting proof of the consistency of the theory with what's called Euro elements, blah, blah, blah. I won't go through the details. The point is, the question of its consistency, New Foundations as it stands, remained open. And normally these questions, it's, to answer a consistency result means showing that it's consistent if something else is that we're confident in. So they're called relative consistency results. And people tried and tried and tried. They could not find a consistency result. And also, the intended model of New Foundations is like not clear. It's not clear kind of what it's about, what it's saying. So people started thinking, I bet this is inconsistent, and it went way out of style. So by the time we're talking now, I mean, by the 70s even, it was like certainly in the realm of set theory, nobody worked with New Foundations. And by the time it was, by the time I was a grad student, it was almost like, you'd get like it was kind of embarrassing if you had interest in New Foundations, like no set theorist in New Foundations, that kind of thing. Well, long story short, there's this guy, Randall Holmes, at Boise State University. And for 10 years or more, maybe, he's felt like he has a proof that it's consistent. And there's only now, these days, there's like, a handful of experts in the world who work on New Foundations. He's one of them. Another one is Thomas Forster at Cambridge University. And Thomas Forster hired some graduate students to try to check this proof. Long story short, as I understand it, they couldn't tell. They couldn't tell whether it's that was the response he kept getting. I can't follow it, to be honest. Well, latest news, as I understand it, is, and this is right off the press. So as far as I know, this is, it would need to be confirmed, but I mean, I have confidence that this is the case. A group of graduate students, or maybe one grad students in tandem with Randall Holmes, got a computer to check it. They broke it down into such basic steps that a computer can follow the steps one by one. And it's a valid proof. So New Foundations is consistent. And all those people who have been, ignoring it for 50 years, because surely if it were consistent, they would have found a consistency proof, are wrong. And yet no one can follow the proof except Randall Holmes. So the reason, if we end up believing this proof is valid, will be because some machine told us. Randall and his machine tells us. And by his machine, I mean a machine we all trust for independent reasons. So we're entering a realm where it's not, I think, going to be super rare that you have a situation where your trust in the theorem primarily stems from your trust in a machine and a program. And you don't understand the proof in the way that we've, since Plato, become accustomed to understanding proof, sort of seeing it all at once, getting the gestalt. You know, you can make an argument to yourself that it must be true, but it, you know, will inevitably involve something like, you know, the machine is trustworthy and it's programmed this way and it says that. So it's got to be true.